Welcome to EducAgent Studio, where a crew of AI agents help us teach and you learn with ease. Here's the problem we'll solve today. Given the function f of x equals 3x squared minus x plus 2, we'll evaluate it at a whole list of different inputs, numbers, variables, and expressions like a plus 1 and a plus h, and simplify each result carefully. The only big idea today is substitution. Whatever is inside the parentheses becomes the new x, everywhere in the formula, especially inside the square. A common mistake is to replace the linear x, but forget the x squared. We replace both. Substitute x equals 2 everywhere you see x. Square first, then multiply by 3, then combine terms. Now the input is negative, so we must keep parentheses to avoid sign errors. The square makes the first part positive, and subtracting a negative becomes plus. Combine to get 16. Same substitution idea, but now the input is a variable. This is already simplified. Parentheses matter again. We're plugging in negative a. Squaring removes the minus, but the linear term flips sign. Final, simplified result. Substitute x equals a plus 1 everywhere. Notice the square applies to the whole binomial. Expand the binomial square carefully. Distribute the minus sign across a plus 1. Combine like terms to finish. This is a key distinction. Multiplying the output is different from changing the input. Use the expression for f of a, then multiply every term by 2. Now we're feeding the function a new input, 2a. Substitute x equals 2a, keeping parentheses for the square. Square first, quantity 2a squared equals 4a squared, then simplify. Here the input is a squared, so every x becomes a squared. Power of a power. Multiply exponents. Simplified result. This is different from f of a squared. First evaluate f of a, then square the whole expression. Use parentheses. The square applies to everything inside. Expand and combine like terms to get the polynomial in standard form. This form shows up a lot later, like in rate of change ideas, so we expand carefully. Binomial square again, now with 2 variables. Distribute the negative sign across both terms in a plus h. Distribute the 3 and combine terms. Every result today came from one repeatable move. Substitute the input everywhere x appears, then simplify. These are the simplified evaluations. Notice how changing the input versus scaling the output produces different expressions. Keep going. Next up, we'll build on these substitution skills in a way that makes the algebra feel even more powerful and automatic.